This video will take you through the steps necessary to add a remote ID module to an ArduPilot autopilot. It assumes that you already have set up a build environment and are familiar with how to build firmware and ArduPilot in general. For this video, we'll be using a Cube Orange autopilot, an ESP32S3 board for the ArduRemote, and a CAN external transceiver to convert it to a drone CAN remote ID. The first step is to create ArduPilot firmware that has OpenDroneID capabilities and install that. Then we'll need to program an ArduRemoteID module or remote ID module with its necessary firmware and parameters. Then set up those ArduRemoteID parameters in the remote ID module. And finally, discuss the way a user would interface and configure the system using a ground control station. So to build the firmware, we'll create a separate branch and create two new HWDEF files and a new params.def based off of the Cube Orange. We'll call the branch Cube Orange ODID, and the hardware HWDEF.dat file, instead of the board ID of 140 for Cube Orange, we'll put a 10140 and enable an OpenDroneID capability in the firmware. We'll do the same thing for the bootloader HWDEF. So it has a matching board ID and OpenDrone capabilities, and then very specific some OpenDroneID parameters. We'll make them read-only. These are set up as shown for drone CAN versus a Mavlink connection. And then we'll go and create a bootloader based off of those files, Cube Orange -ODID, and it'll create and put a bootloader in the bootloader directory. The next thing we do is configure to build the firmware, and we'll do a WAF configure for the OpenDroneID version of Cube Orange. And then we're going to build plain firmware for it, off plain. And I'm showing the automatic upload. Now, this upload, just to show you, will fail because the firmware we're creating has a board ID of 10140, and the Cube Orange, with its standard existing firmware, has a board ID of 140. So this operation, the final operation of loading the firmware, will actually fail, but I just wanted to show that it will fail. The firmware is created and it's attempting to load it onto the board. As soon as the board goes into bootloader mode, there'll be a discrepancy, as you see, of the board IDs. Therefore, we have to force load the software using the uploader.py tool to overcome that board ID check for the load. So I'm using uploader.py with force, and I'm pointing to the firmware that we created in the build step previously. Now it is loading it because we're forcing it to load. You see the board ID discrepancies there. The current bootloader is 140, the firmware is 10.140, so it resists loading that, but we're forcing it. Now when you build OpenDroneID firmware, automatically it puts in the checks such that when the bootloader is finally installed with a board ID of 10.140, it will not ever run any firmware that has been force overloaded into the main firmware area. So now we need to update the bootloader from the firmware that is currently running to replace that old bootloader that's for standard firmware. You can see we're running the OpenDID main firmware, and now we're going to send the command in mavproxy flash bootloader, and you see it's flashed the new bootloader. So now that we've built and loaded and installed the firmware on the autopilot, let's program up the remote ID module, this with ArduRemoteID. So we'll plug into its USB programming port on the module, and now we'll download firmware. We go to the ArduPilot Remote ID GitHub, get the latest release, save it. This is the S3 board, so we'll download that. Then the next thing we've got to do is flash program it with the Expressif firmware programmer that you can download from the documentation. You can get links to that. We'll open up the programmer, select the board, S3, select the USB programming port on that board, then select the firmware that we just downloaded for the S3 board, select it. It's on COM port 15 already. I've set that up, and now it's programming. So now that the remote ID module has been programmed, we'll probably need to set up some parameters such as the UAS ID, type, so forth and so on, as well as perhaps changing capabilities or adding security features. So we disconnect and connect the USB to the flight controller, connect to the flight controller, and you can see it's running the Open DID firmware, and it hasn't been all set up yet, either from the manufacturer side or the user side, so it's giving pre-arm warnings. So we'll go into setup, into the optional hardware, drone CAN, and this is on the second CAN bus, so I click the MAV link for CAN 2. You see the remote ID module, click the menu, get to its parameters, and now we can see all the parameters that are in the remote ID module. Particularly, you will have to change the UAS ID type, and those fields to get that's what's proper for your manufacturing, as well as any capabilities you may change. You can also add private public key pairs for security, which we'll discuss later on, as well as setting up locking levels to prevent parameter or firmware updates via the USB at various levels. We'll discuss those later on in the video. So now we're going to discuss what an end user of the system must do to enable it. Connects to the autopilot equipped with a remote ID module. And there are several things that must be put in place before he can arm and fly the vehicle. So if he attempts to just arm the vehicle, and we'll use force arming here, since we have other things as pre-arm failures. Normally you can force arm over anything. However, you cannot force arm over open drone ID issues or remote ID issues. You see here, it will not even allow force arming. The only way to arm the vehicle, even force arm the vehicle, is to satisfy the requirements. The first is you got to have position information into the ground control station, either by a GPS attached serially, or you could use an Android phone using this app, GPS to Bluetooth, over a Bluetooth connection to the ground control station to provide position information. And that's what we'll do in this case. Simple app, you just start it. If you have a Bluetooth COM port, you attach, connect through that COM port, and you'll be getting GPS position information into the ground control station as you see here. That's one requirement, but it's not the only requirement. If someone attempts to arm the vehicle with just the GPS attached, but failing to enter in some more important information, again, you can't even force arm the vehicle. In some jurisdictions, you'll be required to enter in the operator ID. It doesn't prevent arming currently, but it's required in certain areas. Now, this should allow arming if all the pre-arm checks are gone, or forced arming if all the other pre-arm checks are not resolved. However, there's still a bug in the communication between the module and the firmware, and even though there is already built into the ArduPilot modules its UASID, its type, and UA type, you have to enter these in to allow it to arm. This is expected to be resolved, and I'll actually probably remove this section of the video once that's resolved, but for right now you still have to do that. You see you've got a green light on remote ID, okay. If you're looking at the pre-arm checks, they've been throwing amongst the other pre-arm checks, the remote ID pre-arm check, and every 30 seconds or so you get a set of pre-arm messages. You'll notice the next set does not have that UA type requirement in it. Okay. Now it's able to be armed if you resolve the other pre-arms, or force arm if you don't resolve the other pre-arms. We'll force arm it, and you see it is indeed armed. So now you can see the remote ID module information presented on one of the several phone apps, OpenDrone ID, the OMCS, drone scanner, whatever, and you see the location of both the operator and the vehicle on that application, as well as if you click on the info, you will see all the details. You'll notice that the UASID ABCD 1, 2, 3, 4, 5, 6, 7, 8, 9 comes from the remote ID module. The operator ID came from ArduPilot tester, what I had put in for the operator ID, the location of the vehicle, as well as the operator location. Now we'll discuss security and field updates. The security features provided are a unique board ID to prevent accidental loading of the wrong firmware, firmware checking such that if the incorrect firmware is force loaded, that it will not run, and private key, public key security, locking down the parameters and firmware updates. So we're entering an area now of danger, since doing things improperly can actually prevent any changes from happening to the parameters or firmware in the future if done improperly. Security is provided by public and private key pairs, and this is how to generate your own private public key pair. And make sure that you have Pi monocipher installed, and then use the script generate keys.py to generate a public-private key pair and name the file whatever you want to name it. In this case, I'm naming it Henry. And you see it generates a public-private key pair set labeled by Henry. Now, if we read the public key data, it's a long string. We're going to copy that because we're going to put that in the ArduRemoteID module as a public key. So we're going to add that public key to the module. So we connect to the autopilot remote ID system, drone CAN, second bus. It's where it's located. Go to the parameters and then paste that long string into a public key spot. And then save it. So now that new public key pair has been loaded into the remote ID module. Again, danger zone. Now we can go and lock it. This is the danger part. If you set the lock level to 1 or 2, no changes to parameters or firmware updates can be made unless it's done securely with that private key. So we'll change it to lock level 1, which locks out firmware updates and parameter changes. And to show that, we'll go and try to change the UAS ID. And even though we write it into the ArduRemoteID module, you'll see when we refresh the parameters, it hasn't been changed. That can only be done with a secure signing mechanism, which will be discussed in a future video. So once locked, secure methods of changing params and firmware updates can only be done, and that'll be covered in a new video shortly.